we're trying to find the limit of the difference quotient from the cube root function of 27. And of course, like always, if you just start by plugging in 0, we're going to get 0 on top and 0 on the bottom. So there's more work to do, and you can't really factor cancel this crazy thing. So we have to pull out some real crazy mathematical gymnastics. When you guys were younger, you would learn that a cubed minus b cubed can be factored into this form. It was a long time ago, so I will not be surprised at all if you forgot it, because you probably haven't used it since you were like not even old enough to drive. So that might still be some of you, so that was not a good analogy. But it's been a while is my point. But here we're going to use this thing backwards. So I just want to emphasize something. When we say a cubed minus b cubed equals all of this stuff, we're also saying that if I take a minus b and multiply it by a pattern that looks like a squared plus ab plus b squared, if I were to multiply that out, it would become a cubed minus b cubed. And it would be also great if I could find some way to get this thing cubed minus this thing cubed, because then those cube roots would go away. So what we're going to do is assume that this numerator is this part of this formula, and to the top and bottom of this expression, we're going to add this part. So that's going to imply, and I'm also going to do something else. I'm going to change these purple portions from rational expressions, from radicals to rational exponents. So let me set up a couple things really fast while I pause so that this video isn't 2,000 minutes long. So what I've done here is I've color-coded a couple things. First thing I did was I took this portion up here that was written with radicals and I rewrote it with rational exponents. And we're assuming that this purple part, this numerator, is this portion of this entire expression. And I want to put that orange portion in there as well. If I'm going to say that this purple portion is this a minus b, that means that this is a and this is b. So I'm just putting that as a reminder up here. And ultimately what's going to happen is I'll have this purple portion, I'll put in that orange portion, those two things multiplied together will equal a cubed minus b cubed, which will essentially become this thing cubed, which is just 27 plus h, minus this thing cubed, which is just 27. So what we have to do is figure out what that correct orange portion is, so that we can also do the rest of this problem. This is all over h, and that orange portion I'm going to put on both top and bottom. So let's see. This is a, and I'm going to have to square this. If I square this, I'm going to do this off to the side really fast. 27 plus h to the 1/3. When squared means I got a power to a power. And I'm just going to multiply those powers together. And if I think back to my 5th grade math, 1/3 times 2 is 2/3. So I'm going to have a 27 plus h to the 2/3 plus a and b multiplied together. I'm not going to do anything fancy with this math. I'm just going to go ahead and just stick these two things next to each other. Technically, I could do some things to simplify it, but it's not required, and there's enough math to do right now. And then we have to have b squared, and this is b, and like before, if I square this, it's a power to a power, I'll just get 27 to the 2/3. And I'm currently not interested in evaluating these things. I'm just pushing symbols around. I'm going to pause the video while I write down the denominator again so I can do it neatly. You might pause too, just so you can kind of catch up and reflect on the few things that I've done here. Oh boy. Oh, for a second I thought my mic was off. That would have been bad. All right. So I've rewritten everything, and here's the whole point. While this looks, horrendous, right? The whole point is that this purple part times this orange part equals this blue part, which is a cubed minus b cubed, and this was my a and this was my b. So things are about to get a lot nicer, though not as great as we want them to just yet, but that's fine. So if I cube a, I'm going to have just on the numerator a 27 plus an h minus this thing cubed, which is just minus 27. So that's nice and pretty, right? The top just becomes h. I like that. This h was already here, and then all this stuff is floating around. So again, I'll just stop and I'll rewrite this again. In fact, you could maybe try and finish this off yourselves, but I'm going to just stop to rewrite. So as we said, these 27s will cross each other off, so let's just go ahead and erase them at this point. The bottom's going to look like this, hopefully with better handwriting, and I want to keep in mind that this is the limit as h goes to 0. So really, all these h's will also become 0. And look what else happens. Hooray! Factor, cancel, or just cancel. There's technically a 1 still on the top there. But so what happens is the h that was making the 0 over 0 happen before is now gone. Hooray! I have a 1 on top, and I'm going to put a 0 on the bottom. And I don't know if you can read my terrible penmanship, but this ends up being 27 to the 2/3. Oh, that's the wrong button. So this guy ends up being 27 to the 2/3 when you plug in 0 for h. This becomes 27 to the 1/3 times another 27 to the 1/3. And again, if I go back to my properties of exponents, I'll add those exponents. So I essentially have another 27 to the 2/3. And I have another 27 to the 2/3. And I can look at that if I want to as though I have three things that are all the same. So I can do 3 times 27 to the 2/3. And maybe you remember how to evaluate 27 to the 2/3. It's got to be, the best thing to do is figure out a number that can multiply by itself 3 times to give you 27 and then square that number. So this would be equal to 3. I'd square that 3 to get 9. So I have 1 over 3 times 9. And then here's where I promise you this is just a coincidence, that it ends up being 1 over 27. It's not always going to be the case that we get the reciprocal of the value we were doing in the first place. It's just I don't have a lot of choices for cube roots. I can give you 1, 8, 27. If I want to fit it on a graph, the next one is like 64. It's not a great one to graph. The slope's super duper small. So we got the reciprocal this one time. But that's how it happens, and it's really the hardest part is knowing to use this orange portion, knowing how to use that orange portion, and understand what that orange portion does to get to the place down here. So I hope this is somewhat helpful. I wish I could have done this in half the time, but even as is, I felt rushed. So obviously I'm standing somewhere in the room. Just ask me a question if you need some help. Yay. See you guys probably right now. I'm probably going to this very moment. All right. Oh, I mean, unless you're watching this at home. I'm not. If you're in my classroom, I got weird.